Okay, I'm back. Oh, that took a second. Let's see. Got all of these. Well, that chat has to go now because now I have a new video in. I have to get this chat back. Put that there. Put it there. That. Oh. Oh, God. You know, you would think that I've had this figured out, a lot of this figured out by now. Let's turn the gain down by another. Oh, man. I'm just creating all kinds of problems for myself. All right. Dashboard, let's turn. Yep. And that's good to go. Pause that, it's fine. Ugh. And if I clear, there we go. And if I clear here, oh, no, I guess that doesn't happen. Oh, but it should, okay. Hi, Restream. Now, what was I up to? Let's see. So source, main. So you may notice things happening. Okay, so we have Rust. All right. So now, here we go. Handylicious. Oh, Jesus. Man, you don't even know what's been happening. All right, let's go. So, I've been doing a lot trying to get things to work in this oh, God. Let's snooze that ad break. Snooze that ad break for another 5 minutes. Have I literally been live for like an hour? Okay, well, anyway. So, you see here, I've got all this code does right now. This is mostly demonstration code. Largely, it's just demonstration code to make sure it all works and happens and does the things that it needs to. In fact, let me do something real quick. I want to try. Well, no. Yeah. Okay. So, this code, all it does is blink a green light. What green light, you might ask? You know, how about the green light on this thing? So if I do cargo run, it deploys the code, and then it blinks the light 32 times, and then says, oh, it's like, oh, 32 times. How great. What if I change, and let's go back to small cam. Do 1 hertz, save that. Rust Analyzer is gonna do what it needs to do. I'll run it again. And then it'll blink once per second at 1 hertz. Awesome. So if I do that, but then if I do, let's say, 8 hertz. And then I put it on big cam. I'll just redeploy that. Cargo run. Ignore the red and blue. Ignore the red and blue. Ignore this one. Ignore that. Just ignore, because that's the programmer. The actual project is here on this breadboard. This is just the programmer for the chip for Let me break out the little pointer device here. This is the actual chip. This is the computer that all the code I'm writing is running on. You'll see some. It is a very scientific. It is a very highly efficient pointer device, Hanny. Shut your fucking mouth. So we've got, here's the chip that the code actually runs on. Here is the, here's the programmer that I use to actually program the chip. And then we've got some wiring set up. I can go over wiring later. Eventually what I want to do, it's not interacting with anything just yet. But programmer feeds the actual program to the chip. I've got it set. What I've actually got, where is the chip on here? So this chip right here is actually what's directly connected to this. And it's the translation layer between this potentiometer, which is a slider, left and right. So this chip, where is it? So this chip reads this, feeds the information to this chip. This chip feeds the information back to the computer. Muscle Man Development. Why am I not familiar with that name? I feel it, even though I feel like I should be. All right, let's put that there. Let's see. Oh, Archie. Have you not been in Hanny's streams in a minute? All right, anyway, let's go back to small camera. And I'm gonna see about, since we're here anyway. Clown fart. You're not gonna let me let that go, are you? See, and your name is Inethys in here. But the name I know you by is Deadbeat. So, dude, dude, okay, so, all right, story time. Story time for everybody who's here. Snooze it again. All right, story time. Some of you know I went to a convention called QuakeCon. Inethys might be aware. I don't know. I don't know if you've heard if you've heard the fact that I went to QuakeCon this year. So, you know, I haven't seen a lot of these people in better part of a decade. And I needed to see some of these people that I haven't seen. Really surprised that you oh, actually, I don't know if I should be revealing things about your personal life into this. But so in my head, I'm getting names mixed up, right? So one day I'm waiting for a package from actually I turn down Spotify in my own ears. I'm waiting for a package from DoorDash. And I hear that, okay, so dudes from CVS are coming. They're going to be bringing some snacks, some chips, and some drinks to the hotel. And I walk out the front, and I walk to the front door of the hotel. And this is a huge hotel. You got anyone who's seen my Twitter threads will know. It's a huge hotel. I walk by, and I'm dead certain that I know this guy. Good friend of mine, but I've got the name mixed up because there is another Quake player, or I should say, I know him more from the Warsaw community. And I just, in my head, I was like, that's the guy. That's the guy. Who is it? Oh shit! I need to say hi to him. I haven't seen him in so long. It's Clown Fart. Because there's a Warsaw player named Clown Fart. I was like, hey, Clown Fart, what's up? And he just walks right by me. Gives me like the quick look around and goes, no. It's like, shit. I've just embarrassed the shit out of myself. trying to identify this guy. I'll meet up with him later. I'm sure it's fine. Either he hates me or but you know. But whatever. Later on, I meet up with Jahar and Rotten Rose. You know, I haven't seen them in a decade, and you know, I'd been mentioning to both of them. I was like, man, I can't wait to see you guys. Eventually, I meet back up. I didn't even meet up with Inithis in person. It was during the Quake, not the oh, what server was it? Because over the Quake at QuakeCons segment, every 2 hours we would switch games from Quake 2 to what's that indie one? Shit. And I keep forgetting the name of that game. Doombringer. We launched the Doombringer game, and then I think I actually told Jahar, shit. I actually met up with Deadbeat, and I accidentally called him Clown Fart by accident. I don't know if he relayed that to you about how embarrassed I was about that. But yes, Doombringer. We launched the Doombringer, and then he's like, oh, and then you mentioned, oh, hey, Am, how's it going? It's Clown Fart here. And I hate myself over that shit. But, man, Inithis, it was good to see. It's like, I'm going to... far more confident player. Is Clown Fart still playing? Is he still around? I haven't seen him either. Granted, I only know him from Warsaw, and I don't know anyone who's playing Warsaw anymore. It was awesome seeing you, you and your wife, as well. Like it'd been way too long. I'm really. Did you go to Jahar's after party? I was planning to, but then I got a text from Rotten Rose. Okay. I got a text from Rotten Rose that, unfortunately, someone popped hot for COVID at the after party. Which means, oh hey, I guess I had to host my elderly aunt at my apartment for a week, literally the day after QuakeCon was over, so I had to make the judgment call of not going to the after party. Do you play any fighting games at all, like Street Fighter, or are you still just Quake? I mean, Hanny, if you want a room, if you want to actually go to QuakeCon, if you want to get a Steam Deck, because the way I went was I took a Steam Deck with me. I'm actually not against. You've dabbled in Mortal Kombat, if only. I'm not gonna touch Mortal Kombat, unfortunately. But yeah, I know Jahar is really into Arcana Heart Love Max, which, you could make weirder choices. You could. I'm kind of focusing on Street Fighter. So ArcSoft Games. You played BlazBlue. I have reinstalled BlazBlue. I'll say that. I'm gonna prep the ad break sign for when that comes up because I've snoozed it way too many times. One thing I'm gonna do is Alacrity, or not Alacrity, OBS Game Capture Firefox. There we go. And I will put that in this window. And then I will create another game capture source. Firefox game mode. For that, oh, let's not display that. Capture any window. No, Alacrity. Any window except Alacrity. Now, is that actually... working? Oh, ad break. But since the ad break is running, I'm gonna do something over here. Oh, there goes Hanny with the... There goes Hanny with the... I'm gonna do... Let's see. What if I do this? I'll get rid of Rand 2. Refreshed and ads are gone. Hell yeah. Alright. So... Where's fire? So is it not... Okay. Saw the stream, thought I'd come and say hi. Well, I do appreciate that, man. I'm gonna call you Deadbeat and Inithis interchangeably. I don't know if... is there a preference there? Because I've known you for the longest time as Deadbeat. At least I'm not gonna call you Clown Fart again. So... Let's see. So Randwin, let's see if I subscribe with Prime. This is how you get rid of ads. Awesome. Let's see. Unsaved changes. Cancel. Let's Rust STM32. Okay. If I grab... Which window is it? Which window is it? Not that one. That one. There we go. Okay. So then there's that. And then what if I... Because I have a button now. That is... OBS, let's see, OBS CLI. Actually, let me just do this in the real window. Let me show you all what I can do with it. Let's see, OBS CLI. Is it source, I think? Choose from scene, group item. Is it item? Item toggle. Is it rand win? No. Oh. Is it No, that's not quite what it is. OBS CLI, let's see, help. I'm doing production things. Scene, group item, input, filter, hotkey, virtual cam, stream, record, replay. Scene. What is it? OBS CLI scene? No. I guess it is item. Hide. Rand win. So if I do that, now where is, not hide, dang it, action, switch, current, show, hide, and toggle. Okay, so now, if I, because I'll show you what I'm looking at. Not patch bay, not that. Boom. Okay. So now I'm developing the command that I'm going to use. So if I do OBS CLI hide randwin, hide random window, move that up. Give it another state. And then, so switch state to 1. Or no, switch state to 2. And then switch state to 1. Command is... What software is that? This is Stream Deck UI. So if I do this... Okay. Show random window. So I actually decided to buy myself an OBS. Okay, so now I have, actually, since now the ad break is over, if I click hide random window, shit. OBS CLI, item, hide, rand win. Why did that not work? I should have, man. Item show. Okay. And then in state 1, hide rand. Okay, so then it should be hide. No? Oh, it's hiding the Randwin audio. Ooh. I don't know why it's... That's really weird. Ah, well, okay. So... If I move that back to there. All right. Oh, we got a Listen Up Phones, another viewer. Hey, you're one of, you come from Rotten Rose's crew, right? Anyway, I'm gonna pull this away, Randwin, Rust. Oh, this is probably not gonna be great. The NA, that's pulling up the... That only takes me directly... Oh, that's the create clips thing. You saw STM32 and you more or less came running? Okay, well, I'll, you know... If this looks familiar to you, that's kind of what I had on the docket today. So, I'm gonna go put that back over... Hide that for a second while I, let's see, pull this back up, put this over here, and I think we can just read some documentation, because I'm doing some learning today. Alright, let's see what this actually says. Ah, no. I don't know what's up. Fairly advanced breadboarding. Anything compared to my level is fairly advanced. How long did it take to set up the breadboard? I mean, let's go to Big Cam. It was fairly intuitive. You see the 6 pins there? The 6 pins on the... Where's my highly scientific pointing device? So using my highly scientific pointing device, I've got the 6 pins here. They were generally pretty simple. They're pretty well marked. I've got somewhere in my apartment, which includes on my desk, several spools of copper wiring in several colors. And many orientations. So, I've got the wires. This is all stuff that kind of came with the degree. This is what my degree's in, even though it's not my profession. No, that's called an electrician. I'm an electrical engineer. That's importantly different. Electrical engineers only deal in DC up to 12 volts. Electricians mess around in AC up to 120 volts. I don't fuck around in there. You know what? I'm sure there's electrical engineers that fool around with the big voltages. So right now, where I'm looking, I want to see if I can read a. Now I bought it on. Where is this? Oh, okay. I remembered buying it on Amazon, so. Oh, what is it? ADC, an ADC? Here we go. The chip I bought is and I bought an ADS1115. So that's what this chip is right here, the ADS1115. You can buy it you can buy a little breadboard module for it on Amazon for I don't know how much. So, like, I'm looking at the page. Of course I know how much. It's $6.50, and it's Prime, so you can get it free delivered. So the ADS1115, that's supposed to read this. That is going to be reading this here potentiometer. Potentiometer is going to feed analog data to the ADS1115. The ADS1115 is going to feed that data via I2C back into my STM32 microcontroller. So if I see, what is it? STM32 F1XX underscore HAL. So if we do STM32 F1XX HAL Rust, that library should probably come up pretty quickly. Okay. A Rust embedded HAL implementation for the STM32 F1 family. Is that an F103 blue pill? It is. Someone has been paying attention. Yes, it's the F103 blue pill. So I know it has its own analog devices on it. You have a couple of those? Yeah, I've got a bunch of them sitting around. I like the idea. I know. So before you ask why, I know that the F103 does in fact have its own onboard ADC, but it's only got like one or two, I want to say, actual ADCs on it that can read analog signal. I want to be able to do like 5 of them, which is why I bought an ADS1115. I want to expand that out to do a little bit more. So, oh, there's the pinout. Can I grab the raw file? No. Open link in new tab. Open image in new tab. There we go. Okay. So if I expand this out a little bit. So where on... I can't look at the board directly, but I can kind of look at... So there's 3, there's SDA. Oh, is it SDA? ADS11, what is the ADS1115? It is I2C. Okay. Actually, did I even hook up? No, it's... Yeah, it's hooked up. Looks like it's hooked up. Where is... I2C should be this color? This color here. Oh. I2C should be this color. Oh, yeah. Okay, so there's SDA1, SCL2. That's the... Is that data or... That's data and clock, I imagine, right? Yeah, data and clock. So SDA1 and SCL2. So that is... We're doing... SCL, we're doing I squared C2 on here. So do those inputs do things? Okay. So most of these inputs have a digital state, which is just on, off, and I can just manually do 1 and 0. But if you want to communicate to another thing, usually what you want to do is you want to communicate using a protocol. What kind of protocols exist? Well, if you look on here, physical pin means digital. Pin name, you see there's all of these pins. There's a peripheral A, pin 12, peripheral A, pin 11 here, peripheral A, pin 9. So that's the physical name. Control. Okay, so control means the actual, you can control the chip using these. So there's, so basically this is a lot of JTAG stuff. I don't want to talk about JTAG just yet. Green is analog, so not only can a green pin handle a digital 1 to 0, it can handle analog signals. So anything from 0 to, on here it's 3.3 volts. Some other chips you can do 5 volts. But it can detect somewhere between 0 and 3 volts and then report that as an actual floating point value rather than just a 1 or 0. Timer and channel, let's not worry about that. So USART, SPI, I2C, CAN bus. You might have heard of CAN bus if you've done a lot of stuff with vehicles. If you've ever bought a thing that plugs into your car and tells you what the check engine light actually means on your car, it was using the communication protocol called CAN bus. So these can speak CAN bus as well. You can see the pink CAN RX and CAN TX, receiver and receive and transmit. OBD2 routers can run OBD2. Yes, OBD2 run CAN bus. That's right. Wait, yeah. Maybe I was wrong, because now that I think of it, it's like, wait, no, I was thinking of OBD2 and not CAN bus. But I think OBD2 is another name. It's either another name for CAN bus. OBD2 CAN bus. The difference between OBD2 and CAN. Answer your specific question. What is a bus system? What is the difference between an OBD2 protocol and a CAN setup? It's a language, English. That you can speak as a communication device, telephone. Okay, yeah. So OBD2 stuff. Mystic, what do you got? OBD2 stuff is kind of like the language that they can speak. But the CAN bus is the protocol for the language. Anyway, so blue pill. Right now, what I want to do is I want to configure pins 22, 21, or PB11 and PB10. And which other pin was it? It may not actually be another pin. Yeah, so PB11 and PB10, I want to configure so that they are using the I2C protocol, because that's what the ADS1115 speaks. Once I have that, it's going to be real rough trying to figure out whether the ADS1115 speaks that. But let's see if we have. Go back into the. So we set up the new project. There's the OpenOCD. Let's see. Going further from here on, selecting a microcontroller. Yes. So we've got that working. Examples. Ooh, hello. Rust up add thumb v7. Using a dependency. Oh, by the way, Mystic, how was your birthday? I remember I was only able to stay for a couple minutes. You know, sorry about the whole like the time zones thing. Make us all a little on the weird. Ooh, hello. I2C BME. So I2C. Let's expand this just a little bit and make it. So I2C, we got main. Thanks again for the gifted subs. Was playing 7 Days to Die. I remember. You've got the? Is it Crowd Control or is it another app that does the stuff on 7 Days to Die? Okay, so there's block. Okay, here we go. Here's what I want. Use HAL, I squared C, blocking I squared C, duty cycle, and mode. Got it. Okay, so let's close that. Has their own extension? Oh, okay, so they've got a custom thing. So we take a look at the, oh, no. If I go, nope, let's see. Is it source, main? Okay. I pull back the source and the main. So we say RTT init print, so we're doing that. Init buffers for debug printing. Get access to the cargo peripherals, so we do peripherals take unwrap. Yep. Pack peripherals take unwrap, so we get access to device specific peripherals from the peripheral access crate. Okay. Then we take ownership over the raw flash and RCC devices and convert them into the corresponding HAL structs. So we have flash, RCC, and it looks like we want to do let mutable AFIO equals AFIO constrain. So then we freeze the configuration. Right? Yep. So let clocks equal. So it looks like there's a if 1 is equal to 1. I don't know what that's about. Nope. I don't know exactly what that's doing. Oh, nope. Let's get that. Else. If 1 equals 1. Uh-huh. Because why? Yeah, that is a distinct possibility. Return that, and then so RCC configure dot use HSE of 8 megahertz. Nope. Of 8.mhz. Wait. Freeze, mute, flash.acr. Oh, okay, hang on. Use HSE. And then 8 megahertz. And then that's freeze. Mute. Flash ACR. So we use that. Use HSC of 8 megahertz. Is that right? Yes. Dot sysclock of 48 megahertz. So Hanny, let me ask you this. P clock. Oh, it has been so long. I don't even know what the P clock is. 6MHZ. Freeze. And mute. Have you ever had to write a program as an additional indent on that GitHub tab? Don't know if that matters for this language. It probably does not, but this is just Rust, so a lot of it is... So white space isn't dependent. I can read analog or digital. How many times have you had to program a, how many times have you ever had to write software? Oh, no. Don't need a... if and else are incompatible types. Expected something. Else. Equals if 1 is 1 equals 1. Do that. Yeah, just chat GPT all day. Use HSE 8 megahertz, sysclock 48 megahertz, pclock 6 megahertz, freeze, mutably borrow, flash HSR, ACR. Okay. All right, what's this? Found clocks. Where is... So is that... There's a clocks somewhere. Oh yeah, there's a lot to think of. Well, a lot of it is, there is to be fair, with a lot of like web dev stuff, a lot of the boilerplate is kind of like abstracted away from you. But a lot of this is also boilerplate. So this is pre-written. I'm just kind of going through it with the intent that in my own head, I'm reminding myself that of how all of these things work. Like this would probably, a lot of this would probably just be in a project template. Now, it's in a project template, not so much a framework. Because you think in frameworks, you think in like React or Vue. At the C level, at the embedded level, we just do project templates. It's like, oh, generate me and there's usually... yes, I'm speaking in JavaScript. You want me to talk in Flash or Django? Hang on. I had to sit up in my chair, and my shoulders are fucking killing me. Jesus Christ. Oh, hydrate. Okay, that's actually a good idea. Okay. Clone does not... Stuff is just fascinating to me. Wait till I actually start getting things that work. You haven't seen shit. So if I look in here, so SCL and SDA are PB6 and PB7. Does that actually match up with my expectations over here? No. Where's PB6 and 7? Okay, PB6 and 7 are way over here. Yep, that is true. PB6 and 7. So instead of PB6 and 7, I'm using peripheral B. Let's see. What if... Let's see. Let me close Randwin for just a second so you guys can see what I'm doing. What if I actually just straight up... And I did this. And I said over here. And I just got rid of that line. Okay? And then I said to myself I was okay with randomly copy and pasting from the GitHub. But that should be one over here. So mute AFIO, remove this mute. Oh no, I still need the mute. Okay, so clocks if 1 is 1. I'm guessing that that it's doing that to test to see if there's actually things running, which could be cool. But then if one is 1, we RCC the configure to use the HSE. What's the STM32 HSE? Remind myself, high speed external. Okay, high speed external oscillator. That's what an HSE is. So we're telling it to use the HSE. Guess what that is in big cam mode? Anyone know what the HSE is? See this little guy right here using my... I'm going to use my highly scientific and precise pointer device. Use this thing right here. It's called the HSE. Might also know high speed external oscillator. Also known as a clock. Oh, let's go back to small cam. And what that is that is the actual thing that is spinning at 8 megahertz. And actually tells the thing to do the thing 8 million megahertz. Yes, million times a second. So we use the HSE. The HSE is running at 8 megahertz. The sys clock, the P clock one, PC STM32 P clock 1. Let me make sure I know. Oh, here we go. Clock signals. Clock signals explained. In this article, we explain the various clock signals. Sys clock, H clock, P clock 1 and 2 are all clock signals that you'll see in the datasheet of the STM32 board. The main system clock derived from either the HSI, the HSE, or from the phase lock loop. The high-speed external, the high-speed internal, or the phase lock loop. The sys clock then branches off to peripheral clocks, which feed peripheral devices such as a GPI port, a UART, a SPI. Okay, so sys clock is the main thing. Sys clock is either going to use the internal oscillator, an external oscillator, but since we have an external oscillator, that's what we're using. Or it will use, and I forget what a phase lock loop is. I just know that it's called a phase lock loop. What is P clock 1 and 2? That drives the APB1. Internal oscillator like a heart? That's not an... Like, I know you're joking. I know you're joking, but you're not actually that far off. The chip will have an internal, kind of like... And you can think of the clock as a heartbeat. You're trying to make an analogy? Okay. To better understand. So it does have... in a way, you can think to understand that the external oscillator right here, in a way, you can think of the... Let's move it up a little bit. In a way, you can think of the external oscillator, this guy right here, as kind of a pacemaker. Even though the heart itself, the HSI, the high-speed internal oscillator, is working just fine. Sometimes you want to have a little bit more accuracy. You want to have a little bit more guarantee that the thing is running exactly at 8 megahertz. And that's why crystals, we call them crystals in certain circles, are sometimes well regarded as a way to make sure the thing, if you want to make sure the thing is running at an 8 megahertz and not like dependent on the input voltage and dependent on like all these other factors, how much voltage it's using versus how much voltage it's supplied, how much current's running through it, can kind of mess within the internal oscillator. They're a little expensive, and I say expensive in terms of electrical engineering costs. A crystal is probably just 10 cents, but 10 cents is a lot when you're building boards out and you're ordering them by the millions, right? So yeah, a crystal, this 8.000 thing, that's 8 meg. That's the thing that that's the pacemaker that gives this chip an 8 megahertz heartbeat. P clock signal is a clock signal that drives the APB1. Where is the APB1? Does it matter that with that block diagram was for an STM32 F4? you are correct. It is for an F4. I don't think it matters all that much because sysclock is going to be universal to all, or I imagine that it's going to be universal to all ARM Cortex-M stuff. Which, you know, I went through school learning on a rather than an STM32, I learned on a Tiva 4. And the Tiva 4 is an ARM Cortex-M4. But like just like backing up. The STM32 under the hood is an ARM Cortex-M chip. And a lot of this block diagram is universal to ARM Cortex-M stuff. So, the fact that I'm configuring sysclock, pclock1, etc., that's going to be universal for between the F4 and the F1. So, the fact that it's saying that the fact that this project here is saying that we're going to be using pclock1 at 6 megahertz probably tells me that we're probably going to be using pclock1, the APB1 peripheral. So if I'm going to go ahead and move away Randwin. So then mute GPIOC. I don't have to worry too much about GPIOC for now. I still like the idea that it's flashing. So let mute GPIOB is equal to DP. Actually, you know what? What if I just copy that? GPIOB and then GPIOB split. Boom. And then we're going to configure let SCL equal that and let SDA equal that. GPIOB, PB6 into alternate open drain. And then I'll just do that. SDA, PB7 into alternate open drain. And mutably borrow GPIOB, the CRL, and then I'll boom. We expected semicolons, so let's fix that. Let I squared C. Okay, so up here I need to import the I squared C libraries. Pal. Okay. Colon open, and then I do this. I2C. Blocking I2C. Duty cycle mode. Boom, and then we comma that. Pack. Prelude everything, and then we're also borrowing the timer for the green flashing lights. Boom. Unused imports, blocking I squared C. That's okay. We'll use them here shortly. So let's configure our... instead of going through the loop, actually, no, that's fine. Let I squared C equal blocking I squared C, I2C, and I want 2. I don't want, 6 and 7. I don't want 6 and 7. That's right. Instead of PB6 and PB7, I want PB11 and 10. So SDA is 11. And PB 10. Perfect. So I squared C. I go back to the code. So I squared C2. I squared C is going to be dp I2C2. We give it SCL SDA. So that's going to be the pins. The mode is going to be mode fast. Frequency of 400 kilohertz. And the duty cycle ratio 16:9. Which then the clocks are going to be the clocks, right? 1,000 timeout. Start retries is going to be 10. Address timeout is going to be 1,000. And data timeout is also going to be 1,000. I think that's about right. And then so that's the setup. That's this code tells us that we actually want to enable the internal, where is it? There's an internal I2C translator somewhere in the chip. Let me pull up the block diagram. Again, this is an F4, so we want to do, where is it? USArt, SPI, I2C2. So there's that. See if I can open image in new tab. So there's our block diagram. It's kind of relevant. So we have power management, supply, supervision. We want to use I2C2. It says I2S. That's because there's licensing issues. There's a company that owns the name I2C, so people use I2S and cross their fingers that they don't get sued. I'm pretty sure that's the difference between I2C and I2S. But yeah, we are connecting the actual I2C bus to the pins that you see, the PB10 and 11. And then we give it a, turn this back off. SP2, I2S2, and not oh, is it? Hang on. Oh, you know what? Yeah, you're right. You're right. You're absolutely right, listen up, phones. It is going to be the bus here, I2C2/SM bus. So that's the actual I2C device. There's an I2C. You can think of it as a translator internally. And we are connecting that to the actual physical pin. So just like there's GPIO, there's all these different buses and what gets connected where. It's all kind of fun and games. All right, so back to this over here. But yeah, listen up, phones. Thanks on the call out. I appreciate that. I'm trying. The part of me that's like, oh, I should think in terms of. I should try to. You're learning. I'm also double learning. But I'm also trying to both learn and teach at the same time, which I've heard is good on some levels. Because it's so long since I've actually done hardware. Okay, so there's BME 280. Oh, is there an actual cargo.toml? USB-D. That's weird. BME 280, source, main RS. There is that is an interesting... There's an interesting implication here that there is a crate somewhere, BME 280. Okay, let me pull this back up. BME 280. Rust. Okay, BME 280 Rust. Here we go. I squared C, BME 280. Actually, does that mean that there's an ADS 1115? Ooh, hello. Platform agnostic Rust driver for the ADS 1013, 1014, 1015, 1113, 1114, and the 1115. The 1115 is what I own right now. Yes, I believe we are in fact winning. I'm going to take a drink of my refreshment. My throat is slightly parched. All right, so. Oh, here's the example. Okay. New. Let the ADC equal. Let's see. Create a driver instance. Is there a make a one shot? Embedded HAL. Okay. Let me see what the BME library does. BME 280, new secondary. Okay. So we have the I2C device. Create a driver instance, so there's the device. The ADC is this. IDC dev. Okay, so there's the I2C dev port. The address will be slave address default. Okay. So if I then... nope. We'll save that. We'll go into... Oh, no. Cargo add ADS 1x 1x. Okay. So then we'll pull our actual source code back up. So we have our I2C device. And then we say actually go back up to the top, use ADS 1x 1x. Then ADS 1x 1x and slave address. So then down here, once this is all set up, ADC address is equal to slave address dot default. Yeah. And then we will do ADC equals ADS 1x 1x. New ADS 1013, but instead ADS 1115. We'll give it that and the ADC address. No, oh, ADC address. Oh, whoops. We do things in a JavaScripty way over here. Give it a semicolon. Okay. And then, so we get the device back. And then we make a one-shot measurement. So we loop. So we have our ADC. Let's pull the Ranwin back up again so we have our docs. We set up the ADC. We mutably, actually, so the ADC should be mutable. And then we give it slave address default. Measurement block. Okay, so measurement equals block. ADC.read. Mutable. Channel. What's channel mean? Oh, okay. So we want to do... Yeah. 88, so we have 1x, 1x. We also want channel. Oh, nope. Hang on. There we go. So we do measurement equals block, the block macro, ADC read. We borrow the channel. Differential. Actually, should we save that? Differential. A0, A1. Interesting. Dot unwrap. So, Randwin, let's get rid of that for a sec. Let. Okay, so that should be a let. So let measurement, block it. So we wait for the time. So we're doing a lot of blocking for timer wait, unwrap, set high, set low. Measurement, print line. We'll do R print line macro measurement. Give it the space. All right. So, let's see if this actually works. Oh, it doesn't like something. Let me put this over here. And immutably borrow arguments GPIOB CRL. It doesn't actually. Arguments to this method are incorrect. Okay, let's bring up the documents up again. And mute GPIOB.CRL. Why does it not like? Mismatched types. Expected mutable reference. It is a mutable reference. Do we have? Oh, nope. Okay. So, into alternate open drain. Yeah. Self. So the CR. We are mutably... We should be mutably borrowing. Let mutable GPIO, GPIOB split. DP.GPIOB split. Okay. So then we say PB10 and 11. Why does it not like that? GPIOB CRL. Okay. STM32 IOB CRL. Okay. I was wondering how to interface GPIO register, port register CRL and CRH with HAL libraries. I don't see such an option, and simple CRL line gives an error. It's not going to work for you. Oh, wait, what? CRL and CRH aren't GPIO registers on all chips. On chips that they are, you can just access them. GPIO X CRL and X CRH. That doesn't seem quite like the answer I'm looking for. Because that's very interesting right there. Let mutable now. Let SCL and SDA into alternate open drain. What if I just let SCL equals GPIOB PB10 into alternate open drain, CR is going to be mutably borrowing GPIOB.CRL. And if I save that, are incorrect. Provide the argument. Actually, so if I do that, PB11, SDA, arguments to this method are incorrect. Expected mutable reference. It is a mutable reference. Oh. Huh. GPIOB CRL. What if I don't let it borrow? What if it's CRH? What are STM32 CRL CRH? What are those? You make sure I know. GPIO registers cheat sheet. Here we go. General purpose output, alternate function, output, open drain. CRH is used to set type and or speed of pins 8 through 15. That's right. Pins 8 through 15 of the port, and CRL, it's CR low and high. Okay. Control register high and control register low. Okay, let me just explain what I just learned about myself and everyone around me. Control register high and low. The reason it didn't want to accept CRH is because CRH is meant to control pins 8 through 15 of the port, right? But I was trying to use CRL, which can only do pins 0 through 7. You may notice I'm controlling pins 10 and 11 right here. Pins 10 and 11, which means I need to use the high side control register. And we're on an ad break now, so I'll see you guys in just a moment. But let's take since we're off doing that. We got rid of Randwin. Can we do cargo run? Oh boy. Called result unwrap on error. Value 76. Oh, line, I think it's line 88. Okay. So if I do that, what if I just copy and paste? Is it the same code? It technically is. Differential A0, A1. Why is it giving an error? It's a very important question. Okay, so if I do R print line of that, and we'll say ADC address. Slave address doesn't implement display. Eee. Trait display is not in format strings you might use. Okay. Colon question mark. Okay. So. Oh no. Oh no. What did I just do? Okay. So for this, it's colon question mark that. We run it. Okay, so we're now at a very interesting time in our lives because okay. Well, welcome back everybody. I hope you enjoyed your ads. I decided to go ahead and keep on working a little bit to see where we're at. Apparently this errors out. If you see at the bottom here, we called unwrap on an error, which is very interesting to me. So let measurement, if we don't unwrap, I'm gonna put the documents over here. Unwrap, if this is intentional, prefix it with an underscore measurement. Okay. So instead of any of this, I'm going to... So that's an error. And for now, I'm also going to comment this out. Prefix it with measurement. Dot unwrap Rust. So, okay, let's bring this back up because this is a little bit of a, now we're learning Rust rather than we're learning electrical engineering. Let's see, after looking in the definition of unwrap, in Rust, when you have an operation that may either return a T or a fail, you will have a type, result, or option. E will be the error condition in case of an interesting error. The function unwrap self that will give you an embedded type, if there is one. If instead there is not a T but an error or none, then it will panic. It is best when used if you are positively sure that you don't have an error. Okay. So we do try main. Okay. If let error equals res. Okay. And then we say if let error e equals measurement. Oh, don't worry about that. We print line, we are print line the error, which is actually that should be opening. E. And then grab that. Macro with a similar name exists, our print line. Oh, our pint. I didn't say our pint line, I said I want our print line. Error doesn't implement display. Oh, okay. So is the measurement, yeah, the measurement should be that. Right? All right, so let's move Randwin out of the way. What's our error? Or do we get the error? I squared C arbitration. Okay. I squared C arbitration. Rust. Okay. Actually, can I arbitration? No? Okay. Crate, there's an I squared. Is there an I squared C crate? Oh, okay, so STM32, where is that? STM32 F1 XX HAL Rust. So that, oh no, I need the crate. I need the crate doc. Okay, here we go. I squared C. There's blocking I squared C, blocking instance and pins. Is there an arbitration? Here we go. Error arbitration. Arbitration loss. Okay, arbitration loss. STM32. Can arbitration lost. So somewhere in here. Right, MCU, blue pill board. I power the blue pill board via an external 3 volt source and not via USB anymore. It may have something to do with the double usage of pins PA11 and PA12 with USB. I tried to remap CAN-RX and CAN-TX. Wait a minute. Wait, no. Those aren't... Yeah, those aren't the JTAG pins. PB2, okay. Boot 0, 3.3 volts. PA13 and PA12. Okay, so we're still... No? Okay. Arbitration lost. 11 and 12. Did I use the wrong pins? 11 is SDA. 11 should be SDA, right? SDA should be 11. That's correct. 10 is SCL. Now what does... Is there a diff... Okay, 5 volt tolerant, not 5 volt tolerant. Okay. Uh, 11 and 12 should be 2. Okay, let's see where I went wrong. AFIO. Okay, so where is AFIO? Oh, whoops, hello. So there's I squared C. blocking I squared C, I2C2, DP I2C2, SCLSDA. So should this be and mute AFIO.mapr? Remove the extra argument. Okay. Interesting. So DP I squared C. Should it be I squared C2? SCL SDA. So SCL and SDA are up here. Do they need to be mutable? No. Blocking I squared C. There's I squared C2. SCL and SDA. Mode fast. Frequency is 400 kilohertz. Duty cycle is ratio 16:9. We give the clocks 1010, 1000. That is, in fact, super weird. So if we run it again, it'll blink. Actually, I forgot to read that one line. Default. Won't let you use the AFIO map R. So, let's see. This function, according to this template project, takes 1, 2, 3, 4, 5, 6, 7, 8, 9 inputs. So if I then go back over there, where is this? Okay. So if we go back to the I squared C, is it blocking I squared C? Peripheral in master mode. So we do blocking I squared C, and there's I squared C2. Okay, here we go. Creates a blocking I2C2 object on pins PB10 and PB11. Right? So we have PB10 and PB11. Pins mode. Okay, so I don't know what a map R is. Okay. AF remap and debug IO configuration register map R. So that means okay, so we have 6 and 7 should be over here. Map register. AF remap register. So we only really need it for 15, 3, and 4. Looks like. Okay. Arbitration. It looks... arbitration lost problem. Here we go. Let's see what this does. Do you have an oscilloscope? Look what's happening with the oscilloscope, despite which you might... Okay. I squared C bus master is not in full control of the bus. Any device can pull either SD or SCL low at any time. Hence the arbitration lost. Chances are it is not your code, but a real arbitration lost. The tricky bit is understanding why. So, if I go back, solved. Okay, here's the ADS. Use NB block. Winded, what are you doing here? How you doing, brother? What do you got going on? Oh, what am I doing right now? So the spying on you in my walls. Well, you know you can pay rent. I'd really appreciate that. Let's see. So we have the slave address at default, so that's correct. Where is? Oh, right. Okay, back to the template project. So we don't need the map R. Because it's I squared C2 and not I squared C1, We only need I squared C2. So what is DP again? Let DP equal the peripherals. The device peripherals. Take unwrap. Okay. Pack. So pack. Let's see. That's not the block diagram. That's that. Let's close some let's close some tabs out. Don't need that. I do need that. Okay, so HAL, where are my modules? Pack, peripheral access control. So we grab all of those, we take them and unwrap them. I squared C1, really? DP to I squared C. That's weird. Structs are... Okay, no, never mind. I squared C2. Inner integrated circuit. Owner address, control register, data register. Okay. So then in here, there's a struct for I squared C2. So that's the device we actually want to do. So the device peripheral here in the code. This is the device we want to use. We want to use blocking I squared C. So if we go back into HAL, we go back in I squared C, re-exports, use blocking I squared C, all of this, okay. And then we implement I squared C, blocking I squared C, so that's I squared C2. And then we feed it the actual I squared C device, which we're doing. Then we feed it the pins, which is a tuple of the SCL and SDA pin. What happens if I give it SDA and SCL in that order? Oh, it does not. The trait... Okay, that trait is not implemented, so it actually doesn't like it. It really prefers SCL, the order of SCL SDA. And we give it the mode, we give it the clocks, and the clocks are up here, right? Which, you know what, I'm gonna do R print line clocks. Actually. Clocks. And then add a semicolon. Cargo run. Oh, it does? Ooh, okay, yeah. That does print out interesting information. So what I'm gonna do is I'm gonna comment out these print lines. And I'm going to also, no, there we go. Comment out the error. So there's an supposedly there's an arbitration lost. Actually. So cargo run. So that is actually interesting. Okay, so here's the clocks. So we have the sys clock, we have the ADC clock, USB clock. Oh. We come up here. Okay, so we do have the clocks. So we fed it good clocks. Where pins is a I squared C 2 pins. Creates a blocking I squared C object. Error. I am very concerned about the fact that it's saying that there is a arbitration loss somewhere in there. So mutable BME. If we get rid of the errors here, default, and I'll just go ahead and give us back small camera, just so we can watch the blinky lights. So arbitrate, it's an error I squared C arbitration. Is it, maybe it's not open drain. Instead of into alternate open drain, alternate push pull, into alternate push pull. What does that do? Oh, that gives me another error down here. The trait bound, that is not satisfied. The following other types implement the trait. E0277. CRHB10, push pull. Following other types implement trait. 10 and 11. Open okay. Okay. So it does in fact want open drain. Dang. Okay. Thought I had it. Into alternate open drain. Save that. So the high register, the timer, PC13 into push-pull output. We don't need the Hello Rust line anymore. Don't really, well, we don't need the clocks, but we can appreciate what they give us. Oh, okay. So, ADC read. Mutable channel. Okay, so is that... Let me see if there's something else. Not block, not... Here we go. ADS 1x1x. So where are the channel? Measure signal on input channel 0 differentially to... What if that's our problem? Instead of differential A0, A1, single A0. Instead of differential A0, A1, because they're both floating, single A0. Is that maybe our problem? No. What about A1? A2? No, it's still giving me arbitration errors. Okay, A3. Huh. Platform independent. Single A0. ADC read. So the ADC is the ADS1X new ADS 1115. ADS1X1X. Channel. No. Okay, so mode. Dynamic one shot. Really? Channel selection. So the channel is... okay, channel selection is these. What is that dynamic one-shot? Multi-channel one-shot ADC. Self. So, new ADS. So the new SDA address pin connects, results in the 0x4A effective address. Oh, hang on. ADS 1115 address. Okay, so there's that. Oh, I didn't have documents up. Okay, so ADS 1115, where are... There's the pin package, there's the address pins. Actually, instead of that, 4-channel ADC breakouts. Okay, so there's that. Position the breakout board, solder, wiring. SCL and SDA, that makes sense. Ground. So there's an address pin somewhere. Addressing. Okay, so the ADS 1115 chips have a 7-bit I2C address of 48 and a clever addressing scheme that allows 4 different addresses using just one address pin, named ADR for address. To program the address, connect the pin as follows. Okay. So I'm going to bring up big cam. Oh man, that picture's a little blurry. I might have to take away the camera just a second. All right, so I looked it over. You guys can have big cam. You guys can have, well, you know what? Not big cam. We'll give small cam back. Okay, so I'm connecting it to VIN, which should give it 0x49. It is entirely possible that slave address default, helper slave address, where is slave address? So alternatives, what is default? Clone from. Okay, no. Slave address. New, okay, hang on. Slave address should be, actually C after colon. So slave address should be new VDD. Because I connected the, if I go into big cam and I get my highly scientific pointer device, our slave address is this, our slave address is this red wire right here. And I made it red for a good reason, because I connected it directly to power, which means this is a, yeah, it is connected to the power source, which means it is connected to VDD. So, hope and pray we might have solved our problem. Nope, we still have arbitration issues. What if I just ran through the different solutions here? New ground. Just to try it. Let's see what happens. Nope, still arbitration issues. New SDA. Still get arbitration. New. Oh, nope. Okay, so we still have arbitration problems. Very interesting. Okay, so I do find it interesting that... Okay, so multiple boards. How come there's no... How come there's no... Okay, so what you might notice, if I use my highly scientific pointer device, you might notice that I have some resistors. Right here and right here. Those should be pull-ups, because I'm used to using pull-up resistors on I2C devices. So if you don't mind, I'm going to mute my mic and edit the circuit just a little bit. All right, so you see the pull-up resistors here. I pulled them out of the breadboard. Cargo run. Still in arbitration, so new. And I remembered that I connected the address pin to VDD. Still in arbitration problems. Okay, so what if I ADS 1115 blue pill? STM32. Someone may have written up a thing. Okay. And this here is almost exactly the wiring diagram. So there's the ground, there's the clock, the address pin they connect to ground. What if I were to just unpower the entire thing? And now let's not mix these up, because red should be power, but today red means ground for this pin and this pin only. Let's move it actually over here so that it's easier to get to. There. So now we've repowered. I can... Oh, nope. New GND. Save it. Let's repower the board. Nope, that's wrong pins. Perfect, there we go. All right, cargo run. We're programming the chip again. Still with the arbitration issues. Okay. So ground A1. Oh, actually, Anyone sells hookup wire bundles where there's, for instance, red and then red with a stripe in the same bundle. If you're specifically looking, single A0. If you're specifically looking for wiring bundles under different single A1, A2, and oh no, hello, no, okay, A2, just to test them. Okay, so we're still getting arbitration problems. Red and red with a stripe. I know that I have a bundle of wires that I used for my setup. When I did my controller project, my PlayStation controller. So I know that they do sell bundles. I don't know about your specific question about red and then striped red. I don't know that, to tell you honest. Box of hookup wire, but it's all solid color. Okay. Where the implementation could have used solid and striped. Yeah, I don't know about bundles of wire that do solid and striped. Okay, I'm going to take a look at my circuit. What if I went ahead and I switched it over to PB... If I switched it over to 1, PB 6 and 7. So I'm gonna do some wire adjusting here for a moment. Okay, so address is connected to ground. Yeah. Okay. I've just found my issue. What do you notice? I'm going to see if I can put it up on big cam. And I will put... Not that. There we go. What do you notice that's weird about... Oh, I should probably put it like there. Do you notice anything odd about me claiming that I have wires in B11 and B10, if you can see B11 and B10, on this board? Now, granted, B11 and B10 should be the two white wires. No. What do you notice that's weird? So you may notice the white wires, to me, should have been B11 and B10. In my own head. But they're not yet. Because I looked at the wiring diagram and I saw B11 and B10 on the right of the board near the USB port. On the right of the board with the USB port pointing upward. Has anyone caught that just yet? That's not B11 and B10. Board is upside down next to the pinout image. There you go. You know what? For that, you win yourself a free month of a gift sub to my channel. So I'm... Let's see, B11 and B10. How many is that? That is... B11 and B10 are 1, 2, 3, 4, 5. Oh, shit. 11 is SDA. So I gotta make sure that I don't mix these up. And my watch is telling me something. Oh, that I just paid for your sub. Okay. So I'm on the ADS 1116 or 1115. ADS 1115 has SCL first, so I'm holding in my hands SCL. SCL should be 1, 2, 3, 4, 5, 6. So SCL is 1, 2, 3, 4, 5, 6. And then SDA should be 5. So, if all is correct, I'll show you the new orientation. That might be what solves all of our problems and cures world hunger and destroys COVID once and for all. Always check your circuits, ladies and gentlemen. All right. Small camera. Can you see the green light? Yes, you can. Cargo, run. Failed to open the debug probe. Did you? No connected probes were found. Okay, what if I unplug the probe, plug it back in? Programming. Oh. Hello. It's not giving arbitrate. Well, no, hang on. But it's not blinking either. That's an issue. Well, hang on. We'll comment out this. And then R print line. Did you correct the address? Am I on ground? I should be on ground. Double checking. Let's go to big cam. Yes, address is on ground, and the pins are back to B11 and B10. So our print line, measurement. In the code. Oh, hang on. Are the pins back to B11 and B10? PB11, PB10, yeah. SEL-SDA. I2C, that's the device we're using. I2C2, not I2C, I2C, I'm talking about I2C2. Ground. Measurement. Measurement. That means I can probably unwrap. Cargo run. Oh. So we loop, we say our print line preparing to measure ADC. Do we even get there? Okay, so we do get there. New ground, new VCC, VDD. Why not? Okay. So it does recognize. So single A0. That is really weird that it's blocking. Instead of telling it to block, wait. Okay. Mismatch closing delimiter. So this closes that. Using C or C++? Neither. I'm using fucking Rust. Oh, and I should be. There we go. So, bring this over here. So single A0. See what happens here. Instead of blocking. Why is it not? So block. Seems horribly misguided. Okay, result doesn't imply display. Cargo run. Okay, so it is saying A1. Seems horribly misguided. It seems like there's a lot of support for it these days. I'm interested to see where it's going. So, okay, so at the very least, we know that we have an address. We know that we're maybe kind of sort of speaking to it. But whenever we try to block, so whenever, it's so weird. Oh yeah, cargo's amazing. I wish cargo, I'm noticing that there's cargo, there's a project called UV, ultraviolet, that's aiming to just bring cargo to Python. And I'm like, yes, please. Dear Lord, thank you. Language has no traditional inheritance or polymorphism at all, just traits. I'll tell you, I don't, because I live in the embedded world, I haven't really used them that much. So it's hard for me to tell the difference. I'm not nearly the developer that most people are. Already has pip. Yeah, but pip is just a dependency manager, really. It's not a full-on project manager. Like cargo is. Okay, so we're not getting arbitration issues anymore. But what if we just do, what if we, is it still looping? Is there a problem with loops? Okay, no, there isn't a problem with loops. Okay, block. So is there a reason the block macro is not quite working? Make a one-shot measurement. Okay, let's bring the docs back up. Put them over here where they're actually readable. Let the mutable ADC. So we have the mutable ADC up here. Is the new ADS, and this is 1013, but mine is 1015. Dev should be the actual instance of an I2C project. And then block. Slave address, channel. Oh, use NB block. Ooh. Okay, so I come back over to this example project. So match NB crate Rust. I wonder. Okay. Cargo add NB. Okay. Oh, use NB block. We already have that here. That's weird. Okay, so cargo run. Oh, whoops. We'll copy that. Remove the comment, measurement. NB. Now, is that in this template project here? It is not. That's fascinating. So blocking I2C, duty cycle mode. So BME, new secondary. So we init the BME, we map the errors. We could not initialize BME. Then we unwrap that. BME 280 measure. Okay. So block, instead of block, I'll get rid of NB block here. So cargo run. A0. We are so close. We are really close. Okay. So ADS 1115 STM32 Rust. So awesome embedded Rust, ADS 1115. Intro blog post. Ah. Okay, using the driver. Created a voltage divider circuit. Okay. Here we go. So embedded HAL, ADC one shot. Oh, is this using another... Is this using another thing entirely? That's weird, because it's using a discovery board. This isn't a Linux thing. That is a really interesting that is a fascinating thing. New ADS 1015 address. Okay. Let values, block, channel, ADC read. Okay, so here's what I'm gonna do. I am going to copy copy source main RS to source main RS backup. And then I am just gonna pop up. I'm gonna see what this does. Copy, paste. Oh. Oh, it doesn't, it really doesn't like, okay, hang on. The analyzer doesn't like what I'm doing here. Okay. So we have main. Cannot find function, embedded HAL, trait default. Why? Okay. Actually, let me pull up these documents again, because it is saying Linux embedded HAL. Okay. Using the driver. To use a device from Rust, you have to add to your project as well as a concrete implementation. For example, if you're using the Raspberry Pi. Driver examples repository. Blue pill. Examples. ADS 1015. Ooh, okay. This is okay, yeah. This is actually almost exactly what I want. Okay. So raw, get the raw file for that. I'll do this. Oh, no. Yep. Copy. Paste. All right, so let's go back over that. And let's see if we can read what's actually happening here. So, embedded graphics. We don't need embedded graphics. Actually, before we get rid of embedded graphics, let's see. Heapless. So let's actually split this window. And we'll do source main backup. Oh, and we're on an ad break. So while we're on an ad break, I'm actually going to just kind of like quietly read some of this to myself. Or minor example read it to myself. Okay. So flash is constrained, RCC is constrained, clocks, PB8, PB9, okay. So PB11, I think. B is split. Okay. SCL should be 10. PB 11. And so these should be using the CRLs. We want I squared C2 instead of 1. Get rid of that. Frequency 100,000 hertz. So frequency should be 4. CRH because pins 8 through 15. But remember, we're not using pins 8 through 15. We're using pins 10 and 11. Oh yeah, that actually, you know what? You're actually right. I should have just like looked at what's over here. Yeah, CRH. You know what it is? I looked at, okay, 8 and 9. Yeah, you're right. Oh, nope. Let's see. SCL should be 10. PB 10. PB 11. And they should be on CRH. We want I squared C2. We don't need mapper. 100,000 hertz. We'll do 400,000 hertz. Ratio 2 to 1. Yeah, we'll call it ratio 2 to 1. Expected I squared... What? Oh. I squared C2. No method name hertz for the found type integer in the current scope. 100,000 hertz. Okay, so that would be 100 kilohertz. Right? And then we give it the clocks. GPIOC into push-pull output. Okay, so, yep, there's the LED. The LED should be that. The LED should be push-pull. Right? PC13, yep, PC13. Delay is that. Manager, shared bus. Bus manager simple, new I squared C. Okay, interface. I don't need graphics mode. Cannot find graphics mode in this scope. Text style builder, I don't need that. ADC is new ADS 1015, new ADS 1115 is what I actually have. Manager, acquire. Yes, ad break should. Oh, yeah. Let's turn ad break off. So ADS 1115 need to be able to measure ADC set full scale range. 0 to 5 volt. Wait, really? Okay, hang on. Documents time. I squared C. No, that the ADS 11. Where's the ADS 1115 docs? Here we go. Full scale range. Yeah, here we go. Full scale range configuration. Pretty sure this is still just 0 to 5 volts. Why not? We'll call it that. If it breaks, it breaks. Within 6, 144V. Yeah. Okay, delay MMS. Single A0. Failed to resolve. Manager shared bus. Use of undeclared crate. Embedded graphics. I don't need embedded graphics. Import core format right. Warn unused imports on by default. RTT target. SSD 1306. I don't need that. Unresolved import. HAL delay. Could not find delay inside of F1 HAL. Oh, nope. Let's see. So the F1 HAL, where's the documentation on that? Embedded HAL. Ew. Creates STM32 F1XX HAL. There we go. Now there's a, where's the documentation? Dependence, where's the, there we go, docs.rs, there we go. Okay, delay. HAL timer delay. Is it timer delay? Okay, that looks like that fixes that. Failed to resolve shared bus. Use of undeclared crate. Delay.new. Actually, let's just see if this runs. Cargo, run. Okay, heapless. Now is there a examples? Okay, no, so I need to cargo TOML. Embedded graphics, shared bus. So I do cargo run, or cargo add, shared bus. Cargo add heapless. We have NB, we have HAL. Embedded HAL, libm, Cortex-M, Cortex-M RT. Okay. So cargo run. Use of undeclared type I2CDI builder. Okay. So that's... nope, that's the GDB. Examples. Where's my ADS? ADS 1015. I2CDI. Okay, so interface. We go up. Oh, so we don't actually need I2CDI builder. I2CDI. I2CDI builder. Okay, so interface. I don't need that. Use of undeclared type point. Text.new. Oh, okay. So I don't need... Now, if that's... Embedded graphics, pawns, pistol, binary color, prelude. Okay, yeah. So that's probably included. Display. I don't need a display. Disp. No. Okay. Cargo run. Delay new. Function or associated item not found in delay. Remove the whole use item. Where is delay? So why in HAL? Timer delay. STM32 F1XX. F1XX HAL. Delay. Okay. Let me go back over this. So we have the flash constraint, RCC constraint, clocks, AFIO, the GPIO-B, that's good. There's our data and clock. That's us instantiating the I2C device. We're now instantiating the LED here. I don't know that we really need a delay. Function new is implemented. Unused import. Unresolved extern crate. Expected bang, syntax error, okay. Delay equals delay ms. Okay, so where is delay ms? Timer, delay, ms. Okay. Periodic non-blocking timer that implements blocking delay traits. So that means over here. So we have ADC channel, core format. We don't need embedded graphics. Panic RTT target, got it. RTT target, SSD 1306. Delay. It's really interesting that it says delay, but that is really weird that this thinks that there should be just a delay as a member of the F1XX HAL. Am I maybe looking at the wrong... Okay. Rid of that. See, I hate it. I hate GitHub for this shit. Let's just do the raw file. Okay. So we don't need embedded graphics. We're using MB block. RTT target, we don't need the 1306. That is the F1XX. Let me look over at here. F1XX. Yeah, that is the F1XX HAL. Delay. Does it really not? Unresolved import. Let me just look that up. Unresolved import STM32 F1XX HAL delay. Detailed HAL library reference. Rust. Running VS Code, HAL, STM32 F1XX HAL. Ah, man. No. So there's risk V. HAL. There is no delay, but there is a timer. Delay. Timer, delay. Okay, so we then say max delay release new. So there's our, I'm gonna call it class, even though it's not. Delay.news. So we configure, I guess. Self clocks. Okay, so I guess configure. Is that what we're doing here? The function configure is implemented on what? No function or associated item found for struct timer delay in the current scope. If I then... The function configure is implemented on F timer. Shit. Wait, so then... Get interrupt listen, set master mode. Blanket implementations from into... Huh. Delay MS. Okay, so if we do delay MS, prelude, timer, timer extended, timer delayed, delay MS. If your system frequency is more than 65 megahertz. Okay, so instead of that, instead of just importing timer delay, we'll do delay MS. And then down here, we'll say delay MS 15. Oh, what was it? 50U16. And then we'll copy that, paste it. Tuple struct or tuple variant, found type. So delay. Expected function, tuple struct, or tuple variant. So so if we go back, prelude. So then we go to the timer. What if I don't really care that much about the delay? And we'll just turn the LED off. Cargo run. One error. Okay. Oh, I can just get rid of that. Okay, so ADS 1015 example. Our print line. How many times is that used? Oh, it's not. Okay. So, mutable lines, R print line, values. I think it's colon hash question mark, and then values. Oh, come on. Shit. Okay, what's our... Not slave adder default. We want slave adder new ground, I think. Yes. Damn it. Okay, so if we loop, and We print line. You thought that, oh, it used to be, but if we look in Big Cam, oh, you still can't see it, but I did set it to ground temporarily. And that was part of my, debugging attempts. So LED set low. So our print line looping. So do we even get there? Okay, so we do get to the loop. Unwrap or... So then, actually, what if we get rid of mutable lines? Our print line. Did we read ADC? No, we didn't. Shit. You know what? Why don't we just try and see if there is new BDD. Just see what it even says. Panicked. Okay. So it does understand new G&D. So lines, I don't necessarily care that much. All right, let's see what we're saying here. CRH. Let's just say LED set low. Let's turn the light off. That's interesting. Set high. Why would the LED set? Oh, whoops. Expected. Why would it expect? ADC one shot 139. Oh, why would what? That's weird. Okay, so it's got high and low mixed up. Okay. I guess high is meant to be like another push-pull. Okay, yeah, push-pull. High off, low on. Yeah, that does seem weird. Probably something to do with like the way the transistors are configured. Push-pull kind of stuff that I don't want to think about too hard right now. Bus manager. So it's just freezing up. Unwrap or 8091. What does unwrap or 8091 mean? Unwrap or bar. Let's see. What if I just do, instead of that, I'll grab this one. Single A0. Okay. Our print line. Let mes equal that. Mes that mes. Oh, wait. Let mutable mes equal that, because it's going to be changing very often. No. Well, our print line read, just to make sure that we're not crazy. So supposedly it should block. What time is it? This is nearly 11. I still got some time to kind of try and figure this out. Set full scale range, 6. So we have our... I mean, it runs all of this code. I don't know what shared bus. What is shared bus? That's weird. Is that part of... shared bus manager. Okay, so there is a shared bus lib. Shared bus. Bus manager simple. Bus manager simple for sharing within a single task thread. The least overhead. Bus is equal to shared bus, bus manager simple, new I squared C. And then we have our I squared C thing. And then we proxy bus is equal to acquire I squared C, my device. Proxy 1 is the bus, acquire the I squared C. And then my device new bus acquire I squared C. Dang, okay. So this is for that. Driver examples. Ugh. Full scale, no. Did I get rid of something I should not have? Ah! So there's the lines, heapless string for that. Manager acquire I squared C. The slave address is the default. I don't need default. So why is it thinking Let me look into something real quick. Let me take a look at the circuit. I'm gonna mute Mike. So looking at it, one thing that is maybe a little concerning is that STM32 blue pill ADS 1115. Let me show you the wiring diagram. Nope, that's not it. So you may notice in the wiring diagram, everything except A1, all of the actual pins for the ADS 1115, the actual analog reader pins, are grounded. And I've left mine floating. I can't imagine that being that much of a problem. But it might be worth doing. I may have to do some wiring here. Let me go see if I can find my wire strippers actually, so that I can actually do this. Alright, y'all. I have found the wire strippers. I am going to take a moment. I'm going to disconnect the chip. I'm going to disconnect the circuit. I'm going to do some wire stripping that you guys don't get to see because I don't have cameras set up for that. I'm just going to ground analogs 0, 1 and 0, 2, and 3. Because why not? Let's see, strip that. I think I'm... Yep, 18. All right. Oh boy, I get to have a bunch of PVC, loose PVC bits on my desk again. Okay, so that's A3 grounded. Let's do A2. Okay, we've grounded A2. A1 is being measured on that pin, and that is confirmed that that's the slide pot. Okay. Let's make another. This one will probably be a little bit longer. Got that. Okay. That's long enough so I can trim it. All right. So, big cam. It may not be hard to tell, but it used to be the way the circuit was built was that A0, A2, and A3 were floating. I have decided to ground all of them. And A1, you see the green wire feeds into the potentiometer. Let's just see if this works. Okay. Try this again. Really? Now we have something different. We actually have an on an acknowledge. Okay. That's interesting. Because it's saying unwrap on. Okay. I2C acknowledge. That's very different. Small cam. Let's grab this. This is shared bus. There's that. This is a different error, this acknowledge here. So I2C acknowledge. No ACK received. Oh, you know what? Something else I did. Cargo run. Ah, damn it. So we have new that. Call unwrap on an error. What if we don't block? What if we just don't block? Ah. What about just saying unwrap? What is it doing? Hang on. Ladies and gentlemen, the multimeter's coming out. That's when you know shit's gotten serious. All right, I don't know how easy this is gonna be to read. Oh, that's upside down. Can I do it like this? Okay. Touching the pins together, that brings us down to 0 volts. If I test across power, the power rail, if I test across these 2 pins here, trying not to short them, 3.3. I test across these, 2.0. That's 151 millivolts. Okay. So this is actually just 3.3 volts. So I don't need, maybe there is the issue that I don't need to within 6 144. Okay. So full scale range. Well, I mean, there's definitely, like, I'm definitely doing a lot of modifications to the code here, because there's an assumption that I'm also using this screen. Oh, small cam. There's also this assumption in the official example that I'm using this screen. And there's also the assumption that apparently the HAL just has a delay in it. So I'm doing a lot of modifications. So I'm trying to get it to within 4096. Within 4096. Okay. There's that. So if we run that again, Hmm. Can it read A0? Okay, it can think it can read A0, but it can't. Why is ALRT floating? Now I'm connecting the address pin to power rather than ground. A1 is connected to the pot. Does the ADS 1115 need 5 volts? Is that my problem? I'm gonna try connecting the ADS 1115 to 5 volts rather than 3.3. Actually, before I do that, I'm gonna power the board back up again. Okay, board is powered back up. I'm gonna test that 5 volt pin because there's a pin that says 5 volts on it. Put it to big cam because that's the only way I'm gonna put it to big cams because that's the only way I'm actually gonna see that reading because I can't read it upside down. Nope, that's not 5 volts. All right. Well, it is 10 past 11 here where I'm at. And I should probably be heading to bed here pretty soon. Let me look into this, actually. ADS 1115 3.3 volt. Is your arrangement safe? Yes, perfectly. A good idea. No, it is not. Is run at 5 volts. It needs at least 3.5 volts on the I2C bus. Okay. You can pull up to 5 volts instead, and you won't have a problem. Not only is the ESP8260... Okay, so that's on the ESP. How to use the ADS 1115 with the Raspberry Pi. ADS 1115 data sheet. Ooh, from Texas Instruments. Architecture, input voltage range max, min 0. Features description. Wide supply range. Okay, so supposedly it'll take 2.2 volts. Wait, no. Yeah, okay. Programmable comparator. So supposedly, can you power an ADS 1115 with 3.3 volts? Nope. Okay, so there's some pots. That's the Arduino Leonardo. The Leonardo is a 3.3 volt chip. Uh, 3.3? Low operation voltage. Operating at 2 point... It can be used in any system with voltages up to 3.3 volts or 5 volts without extra circuitry. Ah, 10 past 11. Do I want to dig it out? Do I want to make an attempt to just see what's happening? Let me see if I have it. So the good news is I do have my logic analyzer. problem is, I have to make the judgment call of, because I haven't used a logic analyzer in this environment yet, on this PC. Oh, shut up. Yeah. Turn off the voltmeter. Voltmeter hasn't really been helpful to me today. Well, it's been helpful, but it hadn't solved the problem. Oh, what else are we doing? Can I make this reach? You know what? I don't even have all of the stuff installed to actually do any logic analyzing. I think judgment call is we table this for tonight. I'm gonna put this on my desk so that we know that this is what we want to do next time. In that arrangement. And my apologies to Mr. Listen Up Phones. I know you were kind of eager to see this problem get solved. Hopefully the pixies don't get too angry. That's exactly right. Here's hoping the pixies don't get too angry. I'm gonna see where I'm gonna send all of you guys, because I actually built up a little bit of an audience. The question then is, do I look around for another software and development? Or do I look around for someone I know? You learned a whole heck of a lot tonight. Well, I do appreciate that. That is part of the goal here. That is definitely part of the goal. So let's see. Anyone doing anything? Anyone doing anything in hardware? There's a guy doing Python, reincarnated Python something. My life as a reincarnated Python dev. Oh, but he's doing LLM stuff, and I don't want to mess around with LLM. Versus Let's Encrypt, solo game dev. Is there anyone doing hardware? I see a bunch of game dev, but I don't see... I don't see any hardware stuff. Am I going forward gonna be the only guy doing hardware on Twitch.television? Maybe that's my goal. Maybe that's my calling in life again. I do want to do Scarbot again. Okay. Well, let's see if there's anyone. Would anyone be against sending you guys over to a non-development streamer? Actually, wait. Oh, Shindigs. Well, maybe Shindigs. Well, let's see who's in my following list. Who can I send you to? You know what? Fasani's on. And she's probably still doing her her fundraiser-a-thon. And she is a lovely type. Looks like she's playing Final Fantasy XIV right now, doing her her fundraiser. You know what? Yeah, that's where I'm going to send you guys. I'm going to send you guys to Fasani. Raid Fasani. I will be seeing you guys pretty soon. I'm going to try and do more than one stream a week, but I'm definitely at least going to do one stream a week on Wednesdays. I hope everybody's doing fine. I hope everybody's going to have a wonderful night and a wonderful week. I will see you around.